Have you ever wondered why a steel bridge doesn't melt under the scorching summer sun? Or why your smartphone screen doesn't shatter every time you drop it? Welcome to the intriguing world of materials science, a field that answers these questions and many more. It's the study of stuff, metals, ceramics, polymers, composites, and everything in between. And it's not just about understanding what materials are, but also how their structures give them unique properties that make our lives easier, safer, and more exciting. Consider the 6 property classifications of materials: mechanical, electrical, thermal, magnetic, optical, and deteriorative. Each classification encompasses unique characteristics that define how a material interacts with its environment and how it performs under different conditions. From the strength of steel to the conductivity of copper, or the heat resistance of ceramics to the flexibility of polymers, it's all part of this fascinating science. The properties of materials are not random. They are intricately linked to their structures. So, you might ask, what is this link between the structures and properties of materials? Well, it's like a grand cosmic dance, where every tiny particle plays a part. From the subatomic level, where protons, neutrons, and electrons interact, to the atomic level, where these particles form atoms and molecules, each level contributes to the properties of a material. Let's take a look at a diamond and a pencil lead. They're both made of carbon, but the way those carbon atoms are arranged, that's what makes the difference. In a diamond, the carbon atoms are arranged in a tight, 3-dimensional network, giving it its renowned hardness. But in pencil lead, the carbon atoms are arranged in layers that can easily slide past one another, making it soft and great for writing. These are just 2 examples, but they illustrate a fundamental truth. The structure of a material directly influences its properties. Understanding the structure-property relationship is crucial in material selection. But how do we select materials for various applications? Well, the answer lies in 3 primary criteria: in-service conditions, property deterioration during operation, and cost. Let's start with in-service conditions. This refers to the environment in which the material will be used. Will it face high temperatures, corrosive substances, or extreme pressure? Next, we consider how the material's properties may deteriorate during operation. For example, metals may oxidize or corrode, while polymers might degrade under UV light. Lastly, cost is a significant factor. It's not just about the initial price of the material, but also the costs associated with processing, maintenance, and end-of-life disposal. Materials can be broadly categorized into 4 types: metals, ceramics, polymers, and composites. Metals are strong and conductive, ceramics resist heat and wear, polymers are lightweight and versatile, and composites combine the best properties of other materials. The right material can make all the difference in the performance and lifespan of a product. But what about the materials of the future? Let's dive into some advanced materials that are shaping our tomorrows. First off, semiconductors. These materials, with their unique electrical properties, are the backbone of our electronic age. They've made possible everything from computers to solar cells. Next up, biomaterials. These are materials designed to interact with biological systems, often used in medical applications. Think artificial limbs and tissue engineering. They're bridging the gap between man and machine. Then we have smart materials. These are materials that react to changes in their environment. Imagine a material that can heal itself when damaged or change shape when heated. That's the magic of smart materials. Lastly, nanomaterials, the tiniest of the lot, yet with enormous potential. These are materials manipulated at the atomic or molecular scale, enabling feats of engineering previously thought impossible. The study of materials science is not just about understanding the materials of today, but also about creating the materials of tomorrow. So, why does understanding materials matter? Well, from practical applications to technological advancements, materials science shapes our world. It's all about understanding the properties and uses of different materials. Every material tells a story, and understanding that story can unlock a world of possibilities. So keep exploring and keep learning. Who knows? You might just create the next revolutionary material.